Okay, so this is Chapter 5, Section 2, probably Part 1. And so we're looking at the essential question here, and we've already answered those, and you can see it over here on the left, making a mixture. And we answered the questions under letter A. And then I had students draw a graph, something similar to what they have over here on the left. And we just started to fill it out. Who can do the next column for me? I'll look for a show of hands. Mr. Orweller, give me the next column. What did you have?
3, 9, and 12.
So 3, okay, so that's adding one more cup, and then you added 3 more of the tea. That would be 9, and then for a total of 12. Yeah, that would work. Is there another, does somebody have something a little different that would work? Miss Ryan, what did you have? Let me,
If you double it, you would get 4 cups for lemonade, 12 cups for tea, and 16 cups for the total. Oh, are you talking about that one?
no, you're fine. I'm just going to jump ahead here because you said you doubled it. So I put a little arrow and a times 2. So you said for how many for lemonade? It would be?
4,
And how many for tea?
12.
It'd be 12 because 2 times 6 is 12. And then the total would be 16. Okay? So some of you might have done it that way. I mean, either one of those answers is fine. You're still increasing the batch for a larger party of people. All right. How about this column right here? Anybody have something they could add? Mr. Williams, what do you have?
Oh. 8, wait, hold on. 8, 24, and 32.
8, 24, and 32. Okay. Let's look and see if that would work. And actually it would, so put up 20 points. And then Miss Ryan put up 20 points. And Mr. Orweller, did you put up 20? Okay, go ahead and do so. So here's what I want you guys to look at. When we talk about ratios, sometimes we will have equivalent ratios. So this first column right here shows the initial ratio, and it's 1 to 3, or 1/3, or we could write 1 to 3, and we talked about this yesterday, or we could write 1, 2, 3. Those are all can represent a ratio.
I have a different way.
Thank you. And if you have an equivalent ratio, you should be able to reduce it to sort of the least common, well, let's see, I won't say that. It'd be like reducing a fraction. Let me just give you an example here. If I had a ratio of 1/2, is that the same as 10/20?
Yeah. No.
Are those equivalent fractions, Miss Russell? They are? Yeah, you're not paying attention. Raise points. Those are equivalent fractions or equivalent ratios. Because we could look and see if I multiplied 1 by 10, it would be 10, and 2 by 10, it would be 20. Another way to look at it, if I was to reduce 10/20, if I was to reduce that fraction, Miss Harley, 10 would go into 10 one time, and 10 would go into 20 twice, and I reduce it down to 1/2. That's the same thing. So let me ask you this. Is 3/4 an equivalent fraction to 12/16? Are those equivalent fractions? Or I could write it like this. Is 3 to 4 the same thing as 12 to 16? Are those equivalent ratios? I see some thinking about it. Some aren't sure. Some are saying yes. Miss Ryan, you don't think 3/4 is the same as 12/16?
I think it
You
is.
could be wrong, yeah.
I think it is because.
You think so, Mr. Williams?
Yeah.
How do you, tell me why you think it is?
You could do 3, 6, 9, 12. And you could do 4, 8, 12.
Yes.
Yep.
Jalen got it correct.
Right. Another way to look at it, and I said this a moment ago, can I reduce 12/16? Is there a number that goes into 12 and goes into 16 evenly?
4.
4 goes into 12 how many times?
3.
How many times does 4 go into 16?
4.
That's right. So we could reduce it down to the initial ratio or the initial fraction. So they're equivalent fractions. Okay. Somebody's beeping.
Wasn't me, I swear.
Okay. All right.
The 4 microwave that's hidden in the cabinets.
Let me make up another one here. How about
8 fourths.
is 5/15 equivalent to 15 over 40?
Yeah. Yes.
No.
Well, you could ask yourself, first way, I mean, there's more than one way to do this, but how many times does 5 go into 15?
3.
How many times does 15 go into 40?
2.
2.
Well, 15 times 2 is 30,
Yeah. If you
but
add
there's
another-
10 left over.
I know, but if you add another 15, that would be 45.
Right, yes, I see. Okay, so you see it. Yeah. So as Mr. Williams pointed out,
No.
times 3, it would be 45, not 40. So these are not equivalent ratios. They're not equal. Another way to have done this would have you could have looked at, let me write it again here, 5 over 15, and then 15 over 40. So let's look at this as a fraction for a moment, not so much a ratio. What number will go into both 15 and 40 evenly?
5.
5, yeah. So how many times does 5 go into 15?
3.
How many times does 5 go into 40?
2. Oh,
How many times does 5 go into 40?
8.
8 times? Are those equivalent fractions?
No.
No. And we could actually reduce 5 over 15. 5 goes into 5 once, and 5 goes into 15 3 times. So actually, these are the two fractions that we would, compare, 1/3 and 3/8. They're not the same. So there's a couple different ways you could look and see if ratios are equivalent or not. Let me erase this. And let's drop down a little bit here. So example 1, they're talking about completing ratio tables. Let's see here. And they do it there for you. Yeah, those are decent examples. I'm not going to worry about those so much because this is going to take it'll be a while to go over all this. Example 2. So in this example here, you can see that what they're doing with the water, what they're doing with the water is they're adding 4 cups every time, and what they do with the sugar is adding 1 cup every time. But by doing that, the ratios stay equivalent. So sometimes in example 4 here, it's a good example, they get tricky because they start using fractions. Look at example 4 here. It's talking about pints of paint, yellow and blue, and they start off with 3/4. And then they cut it in half, because sometimes, let's say you're planning to paint a house, and that doesn't happen, and you already bought the paint, but there's a much smaller house you can paint, and you use half as much. So in this case, look at this one here. In the first column, they divide each side by 2. So it would be 3, that's too dark. It would be 3 divided by 2. And that's what they've got right here, 3/2. Because 3 divided by 2 is the same thing as 3/2, which is the same thing as 3 divided by 2. And the blue paint, you can see it right there, it's 4. Well, what's 4 divided by 2? That was pretty easy. That would just be 2. Okay. The next ratio, they multiply that answer by 5. And so then we have 3/2 being multiplied by 5. Hopefully you guys remember how to do that. Thank you, Mr. Lesor. So let's do that. What's 3/2 times 5? What's the first thing we need to do, Miss Scott? Yeah, what's the first thing we need to do? What do we do to the 5? Yeah, 5/1. Okay. Anything else we can do with that? Can we do any cross-canceling? Do you see any cross-canceling we can do? Nope. Okay. So what's 3 times 5? 15. What's 2 times 1? 2. So in this in this second example here, it's 15/2, and you can see what they've got right there. They've got 7 1/2, because 15/2 is the same thing as 7 1/2. How do I know that? Because 2 goes into 15 7 times, with 1 left over, and the denominator, as I've pointed out over the weeks, stays the same. And then, of course, the bottom part, it's 2. Well, what's 2 times 5? That's 10. And so then you can see the ratio they have right here at 7 1/2/10. Hang on with the questions for just a moment. These are the problems I want you guys to do, and I marked them already for you. It's 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the next page, just 13 and 14. Let's look at a couple of these. Trying to get this done under 15 minutes. It's going to be kind of close. Let's take a look here. Number 1, you should be able to answer. How can you tell whether 2 ratios are equivalent? Well, one way is to reduce them and see if they're the same. And I gave you several examples of that just a few minutes ago. Number 3, it says which one doesn't belong. Well, yeah, you guys should be able to do that one. Well, I go over 15 minutes sometimes. It's okay. Number 4 and 5. Let's look at number 5. What are they asking us to do in number 5? It says, write several ratios that describe the collection. So I'm looking at number 5 here. So how many ladybugs are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I counted 12. Is that right? Is it 12?
Yep.
All right, so I could write 12 over, and then how many bees?
4.
Looks like 4. What's another way I could express that ratio?
You could write 12 to 4.
Yeah, 12 to 4,
Or 12 colon.
or 12, and what's that symbol called? What's this called?
Colon.
A colon, yeah. 12 to 4. Those all mean the same thing. So when they say write several ratios that describe the collection, I think that's what they're asking for, and that's kind of what I'm looking for. So just do those 3 ways, and I'll be happy with that. Okay. Let's see, what else here? Find the missing values in the ratio table. You guys should be able to do that. Just remember, when you're trying to figure these out, look and see what's happening. So, for example, let me see here. Number 8, taxis and buses. What's happening in the first and the second column here? Buses, it goes from 5 to 15. What happened to the 5?
Got multiplied by 3.
Right. So, what do you think this would be?
6.
6 multiplied by 3 would be 18. Okay.
And then the buses has the blank one too.
Yep. So you'd keep going. Yeah, I think that's it. I'm going to end the video here. And I want you guys to spend a few minutes working on this.